Okay, here's our last example for this section, and it says investigate the validity of each of the following arguments. Well, so our first one here is all squares are quadrilaterals. All quadrilaterals are polygons. So the conclusion is all squares are polygons. This, in fact, is a valid argument form. It's the if we looked at saying, squares were p's, quadrilaterals were q's. So this quadrilaterals would be q's, and let's call polygons r. So our conclusion is squares, which were p's, are polygons, which was r's. So if I write this out, this first sentence says p implies q. When we join that together with, or we and, the second sentence, which is q implies r, then that implies that p implies r. That form is actually called a chain rule. Sometimes it's called transitivity. Transitivity, if I can spell it. It's also called a syllogism, made very, very famous by Socrates in the Greek times, so as a logical form of argument. So if you know that this follows this pattern, and that's a chain rule, then you know that that is a valid argument. But I want to show you why it's a valid argument. So I'm going to actually go through and do the truth table for you so that you can see why that is a valid form. So I went ahead just to save some time, and I've listed out all the possible combinations of P's, Q's, and R's, just so that we'll have every single combination. Now my first space, I'm going to do P implies Q, so that I will have that column to work with. So remember, in your implications, the only time that you have false is if you have T implies F. So we're doing P's and Q's here. T implies T is T. T implies T is T. T implies F is F. T implies F is F. F implies T is T. F implies T is T. F implies F is T. F implies F is T. So remember, our only false is when we have T implies F. Everything else is true. Okay, now I'm also going to do the Q implies R. So I'm going to do that one so that I can join those two together. So this time I'm using these two columns. So T implies T is T. T implies F is F. F implies T is T. F implies F is T. T implies T is T. T implies F is F. F implies T is T. And F implies F is T. Okay, so now what I'm going to do, I'm going to switch colors here so I can put those two together. I'm going to take the P, not and, whoops, let's erase that off there. And let's do that again. So that was P implies Q. And this time I'm going to do and Q implies R. So that we'll have that whole side here. We'll have that column. So I'm looking at these two columns. And remember, this is an and. So they both have to be true in order for the whole thing to be true. So T and T is T. T and F is F. F and T is F. F and T is F. T and T is T. T and F is F. T and T is T. And T and T is T. Now remember, they have to both be true in order for the whole thing to be true. All right, now I also need a P and R. So or P implies R for the last part of this. So I'm going to have a column for that. So now P implies R. That would go back to these two columns, P and R. So T implies T is T. T implies F is F. T implies T is T. T implies F is F. F implies T is T. F implies F is T. F implies T is T. And F implies F is T. Remember again, the only time that we have false is when T implies F. And now we're going to put these all together. So we have P implies Q and Q implies R. And all of that implies P implies R. So we're going to take these two columns here, this column and this column, and we're going to do an implication with them. So remember, the only time the implication is false is if you have T implies F. So T implies T is T. F implies F is T. F implies T is T. F implies F is T. T implies T is T. F implies T is T. T implies T is T. T implies T is T. And do you remember what we called this? This was called a tautology. When every single possible scenario comes out with truth, then that is a true statement, and that's what we call a valid argument. Now for our next one, we're not going to do all of this, but I am going to show you just for a second why this statement is the way it is. This statement says if a student is, evidently I cannot type, that should be is. If a student is a freshman, then the student takes mathematics. Jane is a sophomore. So the conclusion is Jane does not take mathematics. Well, this is not valid. And I can tell you it's not valid because if we were to say, if a student is a freshman, then the student takes mathematics. So if we were to say, like, this is P and this is R, say, or Q. Jane is a sophomore. Okay, that's a completely new thing. So that's an R. But we've also introduced a Jane, so maybe we should give that a different letter. I don't know, maybe a T or something. So that means T and does not take mathematics. What? That's all so confusing. The problem here is that it only describes what happens if a student is a freshman. It doesn't say anything about what happens when they become a sophomore. And is it possible for a sophomore to have to take mathematics? Absolutely. If you happen to be a math major or an engineering major, you're going to be taking math your entire school career, not just as a freshman. So we can think of possibilities where that would not be a true statement. So this is not valid. This just has way too many variables going on. It doesn't list things out specifically. So this is not a valid argument form.